everybody and welcome to this video. In this video, we're having a look at question 5 of the 2020 Maths Prelim Paper 1. Please make sure that you attempt this question by yourself before watching this video. So let us get started. So what we have over here is, this is a functions question. Again, if you're unfamiliar with the work, please review our function series before attempting this. So we have p of x is equal to log 3x. And it says write down the equation of p minus 1, the inverse of p in the form of y is equal to something. So for the first one, we have to get our inverse. To get our inverse, we know that we're going to have to swap x and y. So in the equation where y was, we're going to put x, and where x was, we're going to put y. Now we have an equation that looks like this. We want to make y the subject, so we're going to take it from log form to exponential form. So taking it from log form, whatever's on this side here becomes the subject. The base of the log is the base of the exponent, and what's on the other side becomes the exponent. So then that is y is equal to 3x. So therefore, p minus 1 of x is equal to 3 of x, 3 to the power of x. Let's have a look at number 2. So it says, sketch your in your answer book. Okay, we don't have an answer book, we'll just sketch it here. The graphs of p and p inverse on the same set of axes and show all intercepts of the axes with one another and the point on the graph. Okay. So it's out of 6 marks, so it's quite a lot of work. So this here is an exponential graph. I'm going to just get 3 points. The 3 points that I'm going to get are just substituting. I'm using the table method to plot this graph. Why I'm using the table method instead of getting the x and y intercept is because we won't have a x-intercept because the x-axis is an asymptote. So here I'm going to put for x is equal to minus 1, 0, 1, and 2, and substituting it in this. So this here is for p inverse. We're going to get 3 to the power of minus 1, which is a third. 3 to anything to the power of 0 is 1, 3, and 9. And we know from the properties of a inverse that for p, it will be, to get the coordinates, we swap the x and the y. So now this will be y and this will be x, and we'll have the same coordinates. That's one of the properties of an inverse. Okay. In terms of the asymptote, we know that for exponential graph, it has an asymptote at y is equal to q. The q value here is 0, so it's y is equal to 0, which is the x-axis. So the x-axis is the asymptote. So for p, which is the inverse, we swap it, so it'll be x is equal to 0, so it's y-axis. So whatever belongs to x in the original graph now belongs to y. Let's go ahead and plot it. So putting in our axes. Okay, so I'm going to draw p inverse first. So for p inverse, okay, so let's just put our thing. So this is minus 1, 0, 1, and 2. And at minus 1, it's minus a third. Okay, so let's just label this. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 3, 4, 5, 6, 7, 8, 9, minus 1. Okay, so I'm going to first draw p inverse. So for p inverse at x is equal to minus 1, it's a third. So it's like a third of the way there. At x is equal to 0, it's 1. At x is equal to 1, it's 3. At x is equal to 2, it's 9. You can see that exponential growth there. It's a positive shape one, so we know we're going to go in this direction. and our asymptote is the x-axis. So I'm just going to draw it by a dotted line, which is y is equal to 0. So then we're going to draw the graph. It's going to approach the x-axis, but never touch it. Oh, sorry, it's a bit bumpy, but that's how it looks. For the inverse, we're going to plot the same point. So -1. Now at x is equal to a third, we have -1. So that point is there. That one is 1. When y is 1, x is 3. When y is 2, x is 9. And this time our asymptote is y is equal to 0. Which is the x-axis. Okay, so again, we show that it approaches but never touches. Okay, sorry, the tail bit looks a bit off. Sorry, let me just erase that. It approaches, but it never touches. And there we have the two exponential graphs. Okay, let me just draw this other one again. I mean, the log graph and the exponential graph. Okay, and what you should note is that it's symmetrical about the line y is equal to x. So all inverses, if you draw a line y is equal to x, it should be symmetrical, you can see. So that's where the mirror is. So that is the graph. So let's just see that we have on the same set of axes, we've got P and P inverse. We show the intercept of the axes. So so this one here is P inverse. For this one here, it doesn't have an y-intercept because it's the asymptote. And for P, it doesn't have an x-intercept because that is an asymptote. I mean, y-intercept because that's an asymptote. So this is P. Okay, and then we needed to show at least one other point. So one other point, so we got three other points. So I mean, we've got many extra points. You don't have to draw that many. At the end, they're just going to look at the shape. Okay. Okay, so here we do the next one. So it says determine the values for x which p of x is less than or equal to 2. So there's two ways of doing this. You can do it with the graph, graphically, and it depends. If your graph is sketched accurately, then you could use a graph. So this here is asking, if I had to put this in English, where is P below 2? Where's the y value of P below 2? Less than 2. So here's P, here's the y value of 2. And for what values of x is it below 2? So we know this x is 9. So it's x is less than or equal to 9. That's where it is below 2. Can you guys see that? So that is graphically. You can do it graphically. So you have a look and then you, but that depends on you drawing the graph correctly. So this one here, we actually did plot at 2. We do know that it's 9. So then it's when x is less than 9. And also we should have between 9 and 0. Okay, so we can't actually put just 9 because it doesn't exist below 0. So its x is between 0 and 9. Okay? So that's how you do it graphically. Algebraically, you could just put in the equation. So P of x is less than or equal to 2. P of x, the equation of P of x was log 3x is less than or equal to 2. You could take this to exponential form. So you have, so we're going to have our x being that 3 to the power of 2. And then that is x is less than or equal to 9. We're just going to also have to add that it's less than 0 this we add because that is the domain of our log graph. Okay, so this is algebraically. Okay, so then it says write down the x-intercept of h if h of x is p of minus x. Okay, so h of x is p of minus x. First, we want to get that equation. So in the equation of p, wherever we're going to see x, we're going to put minus x. So it's log 3 minus x. Okay, so what you can do is you can take this to exponential form if you're not familiar with log form. So you're going to have minus x is equal to log 3 to the power of y. Okay, and then you can get the make y the subject. Sorry, you can divide both sides by minus. And then you can take it back to log form if you'd like. Although I don't know if this is the most helpful way of doing it, but let's continue. So this here is y is equal to log minus 3x. Okay, but basically what we've done was change the sign of x. So that means that it's a reflection in the y-axis. So the y-axis is the mirror. So here we have the y-axis. It's the mirror of p of x. So this gets reflected on this side over here. So it literally goes, let me draw it in a different color. So this gets reflected on this side here. So it looks like this. Sorry, again, my drawing is not great. So it's reflect the y-axis is, so our x-intercept, x-intercept will now, was 1, now it will be minus 1. So the x-intercept now is minus 1 and 0 because it's reflected about the y-axis, the mirror, because you're changing the sign of x. Okay. I hope that you have understood this example. I hope that if you have not understood anything, please watch our series on functions and retry this question, and then please try our others. Thank you for watching. Bye.